In today's video, we are going to see the next concept, and that is Lewis concept of acid and base. This Lewis concept was totally based on electron transfer. Like the previous concepts, they were based on proton transfer, or you have to dissolve a substance in water in order to know whether it is an acid or a base. Lewis concept, a very nice concept to define an acid and a base, and it was totally based on electron transfer. Now when I say electron transfer, one species will gain electron while the other will lose it. But there is no complete transfer, it is only through a coordinate bond. So let us see what is a Lewis acid. So according to Lewis, acid is a substance that can accept a share electron pair. Now what it means is, say for example, I have the species like H plus which are electron deficient. It can accept, means the bond will be in this way, from any species, say B, which is electron rich. When I say it is electron rich, there must be a negative charge or a lone pair on it. So when a substance will accept this share of the electron pair, then I will call this as Lewis acid. To understand this better, let us take one example, that is water and H plus. Now if I draw water, how I will draw that is in this way. There are two lone pairs here and I will have a proton here. If you see this is electron deficient and this is electron rich. So the electron pair will be shared in this way from this to this. Now which is a Lewis acid, as it is accepting, so this is accepting it, so this is Lewis acid according to Lewis. So what is a Lewis acid, students? Lewis acid is a substance that can accept a share in an electron pair. Now let us see what is a base according to Lewis. Now if I say acid is one that can accept, what is a base? So according to this, base is a substance that can donate a share in the electron pair. Now what is the meaning here? That can donate. Now students, who can donate? Only the species which are electron rich or having a lone pair on it or having a negative charge on it, they only can donate this electron pair, and then this is what the concept is. When I say a Lewis concept, we have examples with acids as well as bases which are bonded to each other by means of a coordinate bond or a dative bond. To understand this, let us take one example, and that is BF3. And here I am taking ammonia, that is NH3. You know that nitrogen has a lone pair here. Now if I see those fluorine atoms, they are electronegative, and so they will pull the shared pair of electron towards itself, making this boron electron deficient. So it will have a del positive charge. This is an electron-rich species, so what will be the direction of the bond will be like this. So who is donating the shared pair is nitrogen from ammonia, and to whom it is donating, that is the boron of boron trifluoride. So this is a Lewis acid and this is a Lewis base. Both are bonded to each other by means of a coordinate or a dative bond. Let us see the next example, that is hydrogen and water. As I said, hydrogen or a proton, if I take H plus, and if I consider water, then water, oxygen has two lone pairs. So the flow will be in this way. So what is this? Is del positive, this is del negative, this is Lewis acid, this is Lewis base, and this is what you get is the hydronium ion. This is how it is formed. So you have a dative or a coordinate bond. So this is what is Lewis concept of acid and base. Now let us see what are the rules to classify the particular species as Lewis acid and Lewis base. The first and the very important thing is, if the species is having a negative charge, species having a negative charge. Means what, students? If it is in the anionic form or anionic form, then I will say they all are Lewis bases. Say for example, chloride, fluoride, I will use it as halogens. Then you have NO3 minus, SO4 2 minus. Those who all have negative charges on them, they all are Lewis bases. Now let us see some more examples here. I can have phosphate here. So PO4 3 minus, they all are Lewis bases. If I say negatively charged, they are Lewis bases. Then what can be the species with the positive charge? So species with or having positive charge means what, students? They are in the cationic forms. They all are Lewis acids. Say for example, I have Zn2 plus. I have, say for example, some of these species having positive charges like Ba2 plus, I have Al3 plus. All the examples what you have, Ag plus, H plus, they all are Lewis acids. Now this is about the charge carriers. Now if I say there are some neutral species, then how I can classify them as Lewis acid and base? For that, let us see the third rule, and the rule is electron rich species. Third rule is electron rich species having lone pair on nitrogen or oxygen of the molecule, then they will behave as Lewis bases. Say for example, we have NH3, you have C6H5, N, you have R, NH2, then all the reagents what you use, that is lithium, aluminium hydride, you have methyl magnesium bromide. This is from what you use in the Grignard reagent. You have ethyl C2H5 magnesium bromide. They all are Lewis bases. So this is what you have to learn. When there is nitrogen, lithium, aluminium hydride. So they all are the examples for Lewis bases. The fourth rule is some of the neutral species like PCl5, neutral molecules or species like PCl5, SnCl2, SnCl4, PCl3, SO2, CO2, many more, students, that ZnCl2, they all will act as, or even I have NCl3, they all will act as Lewis acid. Very difficult to learn the full list of acids and bases. So let us have a shortcut there. But before going for the shortcut, let us finish off the last rule. And the last rule is those particular species or atoms that have 6 electrons in their valence shell. Means what, student? The atoms which will complete their sextates, they are Lewis acids. I am talking about oxygen atom and sulfur atom. If you see the electronic configuration, it will be 2p4, 1s2, 2s2, 2p4. It will be 3s2, 3p4. So those which are having, if I see here 2s2, so having 6 electrons in the valence shell, so they are completing their sextate, and so they are Lewis acids. So those are the rules to just classify the given species as Lewis acid or base. But there is a shortcut to know whether the given species is a Lewis acid or a Lewis base. For that, let us take the example of PCl5. Now you don't know whether it is a Lewis acid or a Lewis base. Always remember, if a positive charge is created, then it will be a Lewis acid, and a negative charge, if it is created, then it will be a Lewis base. Whether it is a partial charge or a complete charge. I am talking about a cation and an anion, or the partial charges. For that, the given molecule, I will draw the structure. So if I draw the structure will be something like this. I am drawing a rough structure. I am not going for the geometry, a rough structure. Now if I compare the electronegativity, chlorine is more electronegative as compared to phosphorus. So the electrons, they will be pulled in this direction. So if the electron shared pair is pulled outwards, then what will happen to phosphorus? It will become del positive. The moment it becomes del positive means what it will act as, student? It will act as a Lewis acid. So PCl5 is a Lewis acid based on Lewis concept. Let us go for ammonia to know whether this is applicable. So ammonia is NH3. So how I will draw this? This is H and H here. Now you know that there is a lone pair. So as there is a lone pair, it is electron rich. So it is a Lewis base. But let us see this shortcut method whether it is applicable. So if you see this hydrogen, hydrogen is an electron donating group. So if it donates the shared pair of electron in this way, what will happen to nitrogen? It will become del negative. The moment it becomes del negative, it is a Lewis base. So this is a shortcut what you have to remember. Few more examples I will take. Say for example SnCl2. Chlorine on both the sides means it is electron withdrawing, making this del positive. If I go for SO2, if I arrange sulfur dioxide, I am not talking about the actual structure, I am only talking about the rough skeleton. So oxygen is more electronegative, so it will pull this in this way, making it this. So SO2 is Lewis acid. If I see carbon dioxide, it is something similar. So this is what it becomes del positive. So carbon dioxide is also a Lewis acid. So this is how you can classify a given species as Lewis acid and a Lewis base. So this is about the Lewis concept. As such, there is no limitation. Various substances, they can be classified on the basis of Lewis concept. You don't have to dissolve the substance in water. You don't require the requirement what Laurie Bronsted was requiring, that is a proton to be present. So as such, we accept Lewis concept for most of our studies. Thank you, students.